Alright, so I'm going to take a couple minutes to let you guys know about the Molar Road Map. So go ahead and turn to page 100 and 101 of your notebooks, and specifically we're going to focus on page 100 right now. So in the middle of page 100, I want you to write moles, just like this. Now with the mole, we can convert it to three different things. The first thing I'm going to show you how to do is convert moles to liters. Okay. Now it's important to note that when we convert moles to liters, this is only referring to gases when they're at STP. So STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius and 1 atmosphere of pressure. So this means we can't use this method to find the volume of water because water is not a gas at STP. So this only applies to gases when they're at 0 degrees Celsius and 1 atmosphere of pressure. So when that's the case, we know that 1 mole of a gas is equal to 22.4 liters. And we'll use this conversion factor anytime we are trying to convert between moles of a substance and liters of that substance as long as it's a gas at STP. The next step that we're going to convert to is particles, and this is where we get to Avogadro's number. So Avogadro's number allows us to convert from moles to particles of a substance, and those particles are either atoms or molecules. Now again, for each one of these things, I'm showing you what we can convert between, and the conversion factor allows us to do it. So up here we had the conversion factor for liters. Now the conversion factor here for particles is 1 mole is equal to 6.02 times 10 to the 23rd particles. So that means every 1 mole of substance is 6.02 times 10 to the 23rd particles. The last thing that we can convert to is grams. So I can convert to grams of a substance, and the conversion factor I use here is 1 mole is equal to a certain number of grams. Well, we don't know what the actual number of grams is because it depends on the chemical itself. So to get this number right here, you have to refer to the periodic table, and that is called the molar mass of a substance. Okay, and so for example, if we were dealing with water, so if we look at hydrogen, hydrogen has a 1 on top for atomic number, and then 1.01 is the average atomic mass, and then oxygen has an 8 up here, and then a 16 down here. So that's what it looks like on the periodic table. So when we have water, H2O, okay, 1 mole of hydrogen atoms weighs 1.01 grams, the average mass, and 1 mole of oxygen atoms weighs 16 grams. So in other words, if I had 6.02 times 10 to the 23rd hydrogen atoms, it would weigh 1.01 grams. So now, if I want to find the total mass of this water molecule, I have 2 hydrogens, so that's going to be 1.01 plus 1.01, and then I have one oxygen molecule, so that's 16. If I add those all up, that ends up equaling 18.02 grams per mole. So that's how we would get this number here, and that would go right here. So that leaves this as being our third conversion factor, and again, we get that number from the periodic table.